All right, let's talk about tsunamis. We all have this mental picture of how they work, right? These terrifying forces of nature. But what if that picture, the one we've all been taught, is missing a massive piece of the puzzle? We're about to dive into a really fascinating, kind of radical new theory that might just challenge everything you thought you knew.
So, the classic explanation, it's simple, it's powerful, it's what you'll find in pretty much any textbook. But here's the thing, it has this one critical flaw, this nagging question that it just can't seem to answer. And answering that question, well, that might just change our entire understanding of how these incredible waves are born.
Okay, so before we get to the new stuff, let's quickly lay out what we think we know. Here's the standard explanation. This is what's usually called the underwater shove theory. The idea is pretty straightforward. You get a huge earthquake or maybe a massive underwater landslide, and it suddenly shoves the seafloor straight up. Just bam! It acts like a giant paddle in the water, just heaving this colossal column of water up and out. And that's what creates the wave. It makes a lot of sense on the surface, right? A big push equals a big wave. Simple. But here's the mystery, the big problem. If it's just a push from below, how do you explain the one thing that countless eyewitnesses report? You know what I'm talking about. The ocean dramatically pulling back. The water just vanishes from the shoreline, receding way, way out before the wave ever hits. Think about it. A push should only send water forward, right? So this incredible, terrifying moment, the great water withdrawal, it isn't just some weird side effect. No, it's a huge, critical flaw in the standard theory. And this is really the heart of the problem. On one hand, the theory says you get a shove, right? Water should immediately get pushed towards the coast. But on the other hand, what people actually see, what's observed time and time again, is a massive pull away from the coast first. The two just don't line up. It's a fundamental contradiction.
And this is the crucial takeaway here. A simple push upwards, a vertical shove, or even a giant rock falling, it just can't account for the sea pulling back like that. The physics doesn't add up. There has to be some other force at play, some other mechanism that we've been missing.
So what could that be? This is where we have to totally shift our thinking. What if the trigger for a tsunami isn't a simple shove from below? But what if it's the entire underwater mountain range moving sideways?
And that brings us to this novel hypothesis, a theory of moving mountains. Okay, so this is called the mountain shift theory. The argument goes like this. Tectonic activity doesn't just push the seafloor up, it causes an entire underwater mountain range to shift horizontally. Now, as this massive thing moves, it creates this huge low-pressure zone, basically a void in its wake. And what does a void do? It acts like a vacuum, sucking all that ocean water backward, away from the coast. And there it is. That's our mysterious water withdrawal.
So let's break it down. It's basically a three-step process. Step 1, the underwater mountain range starts to shift horizontally. Step 2, this creates that void behind it, which sucks the ocean water away from the coast. That's the pull. And then Step 3, the forward momentum of that huge mountain range violently shoves all that water forward. That's the push. It's a pull, then a push. And that sequence, it explains exactly what eyewitnesses have been describing for centuries.
All right, a theory is one thing, but how does it hold up in the real world? Let's put it to the test with a huge case study, the devastating 2004 tsunami in Sumatra. When you look at the timeline of events, it's pretty telling. First, you have the massive earthquake off the coast of Sumatra at about 7:58 in the morning. Now here's the crucial part. Minutes later, sources noted that local island mountain ranges had actually shifted, and then hours later, the devastating tsunami hits coastlines all across the Indian Ocean. The sequence of events just seems to fit this new model really, really well.
And this really gets to the core physical principle of the whole idea. There's a quote from the source material that sums it up perfectly. A moving mountain can, and even must, pull the still ocean water before it can push it. I love that. The pull isn't just an accident or a side effect, it's a necessary first step in the process.
So, just to recap why the 2004 event fits so well. First, the location of the earthquake corresponds to where these mountain ranges shifted. Second, the sheer scale of that tsunami. It affected the entire Indian Ocean basin. That points to something absolutely enormous being displaced, like a mountain range. And third, and maybe most importantly, all those widespread reports of the sea receding. They align perfectly with this pull-then-push model.
But, this is science. And in science, the puzzle is never really solved, right? There are always unanswered questions.
And the author of this theory is very clear about this. This is a plausible solution. It's an idea that seems to fit the evidence way better than the old one, but it's not the final, complete answer. That's not how it works. Real scientific progress is all about that humility, about always asking the next question.
Which leaves us with one more really fascinating question to think about. Okay, so if the initial trigger was off the coast of Sumatra, what was the specific mechanism that caused the coast of India and Bangladesh to be so incredibly devastated? The mountain shift theory gives us a new lens to look through for sure, but there are still deep mysteries in this puzzle. It really leaves you wondering, what other massive forces are at play down there in our deep oceans?